measure of progress. The development engineers at Mercedes-Benz set out to build a spacious, compact vehicle, expertly engineered on the basis of both new and proven components. More comfort, more utilizable space, appointments uniquely tailored to individual tastes, and a design which unites typical Mercedes styling features in a completely new way. These are the hallmarks of the successor to the 190 series, of which 1.9 million models were built. The new C-Class. The first sketches of the new C-Class were made in 1986. The target was a considerably larger interior than that of the predecessor, but with no more than 3.9 centimeters added to the exterior length. The designers had the task of incorporating numerous new and striking styling elements in the C-Class, giving it an unmistakable identity within the Mercedes model family, while at the same time not breaking with the traditional Mercedes values. While modishness was to be avoided, the shape had to embody that distinctive, enduring modernity which distinguishes every Mercedes. Appealing to contemporary tastes without succumbing to passing trends. The final approval of the body shape marks the last stage of exterior and interior design. Like the design, the engines too have moved on a generation. The petrol engines develop higher torque in the lower and middle engine speed range, and their consumption and emissions have been reduced at the same time. Cross-flow cylinder heads with 4 valves per cylinder and electronic engine management ensure efficient combustion. The 4-cylinder petrol engines have outputs from 90 to 110 kilowatts. The voluptuous 6-cylinder engine features a variable intake manifold and camshaft adjustment. The all-electronic high-tension ignition with 3 twin-spark coils is situated under the cylinder head cover. The result, 142 kilowatts of power and a maximum torque of 270 Newton-meters. The intake system of the proven 2-litre diesel engine has been modified to improve torque, particularly in the lower engine speed range. Exhaust gas recirculation and oxidation catalyst, which are fitted as standard, reduce pollutant emission. The first passenger car diesel engine in the world with 4 valves per cylinder. Oblique injection, which serves to reduce particulate emissions, has been retained. Due to the 4-valve design, the pre-chamber can now be positioned centrally, thereby ensuring better cylinder charging and hence more efficient combustion. Computer analysis and high-speed photography show that combustion in the 4-valve cylinder with 8 combustion jets has advantages over the conventional design, which can be recognized here by the 5 combustion jets. Further technical features, such as map-controlled electronic injection, result in increased torque, while at the same time reducing fuel consumption in the most relevant driving range. The standard oxidation catalyst and hybrid rear silencer are new. Emission measurements prove the effectiveness of the various measures. In addition to extremely low emission of gaseous pollutants, particulates too have again been reduced by about 30%. The particulates are retained in a filter disc during the test and subsequently weighed. The engines were refined and subjected to endurance trials on the latest test rigs. Under high thermal loads, the major assemblies were adapted to the various models in extensive trials. More than 200 measuring points throughout the vehicle supplied the necessary information. Temperatures of over 50 degrees Celsius in Death Valley provided ideal conditions for designing the dimensions of the heat shield. Mercedes-Benz vehicles are expected to have a long life. With the aid of computers and the latest test rigs, every conceivable type of operating stress was simulated. Trials on bad roads and in a variety of climatic conditions played an important part in the development process. Exciting driving and a large margin of handling safety, even in emergencies, were important priorities for the new C-Class. The neutral handling characteristics, with a slight tendency to understeer, are the product of intensive tuning, for example on the driving dynamics simulator. The changes in wheel position as a result of transverse, longitudinal and vertical forces are measured in order to compare the relative merits of different running gear designs. Additional information is obtained from computer analysis and from driving dynamics measurements carried out at special test sites. Safe handling is more than just good behavior on dry roads or good sidewind characteristics. Safety in extreme weather conditions is enhanced by the proven automatic locking differential, which is available for both the 4- and 5-cylinder vehicles. For the C280, a traction control system with acceleration skid control and integrated friction torque control is offered. For the first time, this system is now also available in combination with a manual gearbox. The warning light in the instrument cluster shows the driver that the acceleration skid control is intervening, which indicates a critical driving situation. The brakes are a vitally important active safety system. The cross-sectional view of the brake disc at the top right shows the sudden change in temperature which occurs when braking to a standstill from a speed of 150 kilometers an hour. Trials in a vehicle with a full payload on a steep mountain pass make extreme demands on the braking system. But the larger brakes pass the test with flying colors. The further refined ABS system is, of course, standard equipment. Braking tests on surfaces with different friction coefficients, in this case good grip on the left and a slippery surface on the right, show that without corrective steering, the vehicle deviates from its course only very slightly, and that only minor steering corrections are required to keep it firmly on track. The C-Class sets the standards, not only in active safety, but above all in ride comfort. Mercedes-Benz demonstrates convincingly that there need be no conflict between high active safety and excellent ride comfort. The new double wishbone front axle results in reduced vibration and noise. Since the shock absorbers play no part in locating the wheels and so are not required to absorb transverse forces or moments, their responsiveness has been considerably improved. Extensive rig testing of the whole vehicle allowed all the relevant axle parameters to be coordinated in order to achieve the best possible ride comfort. During testing, defined load collectives were reproduced on a servo-hydraulic test rig. The overall design is based on a new double wishbone front axle, a modified version of the proven multi-link rear suspension, and a 25mm longer wheelbase. In the sum total of its properties, the new C-Class sets standards in terms of cultivated, comfortable, and relaxed motoring. The multiply adjustable seats, optionally with electric control, are anatomically contoured with a steel spring core, foam rubber damping elements, and breathing upholstery. Front seats with multi-contoured backrest are optionally available. The amount of air in the integrated chambers can be finely adjusted to adapt the contour of the seat precisely to the individual occupant. The ergonomic positioning of the controls, easily readable instruments and displays, and optional fore and aft adjustment for the steering column help to keep the driver fit and alert. The heater with optional recirculating air mode, the air conditioning and the automatic temperature control all help to ensure a comfortable climate. The temperature of the interior is electronically monitored. The quantity and distribution of the air supply have been increased, and the heating system is more efficient. The optional pollen filter traps all particles larger than 5 microns in diameter. All the systems were examined independently of the vehicle on test rigs. Body components were subjected to extremes of heat and cold in climate chambers. The windscreen defrosting system, for example, must be absolutely dependable. Road trials in wintry mountain terrain, in the Arctic Circle, or in extremely hot and dusty conditions are a vital part of the development process. Systematic noise testing is carried out in a sound-absorbing chamber. Noise testing by means of the artificial head method demonstrates the quietness of the C-Class interior. The ever-increasing number of modern, highly integrated electronic systems installed in the vehicle must be effectively screened against electromagnetic radiation. Naturally, accident safety was also a key criterion in development of the new C-Class. Using information from Mercedes-Benz research into actual accidents, the proven safety systems in the new C-Class incorporate further refinements. The protective function of the deformation zones was further improved by a large number of harmonized measures. In computer simulation of different types of impact, the consequences of alternative designs can be established without delay, thus allowing much more time for refinements to be made. In extensive preliminary tests, the vehicle structure and the more comprehensive occupant restraint system were carefully matched to one another. The compact models of the new C-Class, too, are now offered with an optional front passenger's airbag to complement the standard driver's airbag, which has proven itself countless times. The offset frontal impact at 55 kilometers an hour with 40% overlap is a tough test of the vehicle design. With structural reinforcing elements in the front section, the vehicle is better able to withstand collisions where the frontal overlap is even smaller. The through-loading facility and the fuel tank under the rear seat were tested using new techniques to maximize cargo and fuel tank security in the event of an accident. A further emphasis in vehicle safety development was to protect occupants in the case of lateral collisions. Coordinated structural modifications in conjunction with laterally rigid seats and selective use of padding ensure maximum safety in a lateral impact. The roof drop test demonstrates the strength of the roof structure under extreme stress. Rollover tests provide further information by which to judge the effectiveness of occupant protection and the crashworthiness of the fuel system. This test, too, proves the safety of the C-Class. The doors can be easily opened and the car can still, with caution, be driven. CFC-free production, marking of the different types of material, ease of dismantling and recycling are principles by which Mercedes-Benz sets great store in its use of plastics. It's possible to produce all the parts shown here from recycled materials. With the various design and appointments versions of the new C-Class, the customer has an opportunity to give expression to his own individual lifestyle. The classic version has more comprehensive basic appointments. The Esprit version has a more dynamic accent, with attractive colors, particularly in the interior. The Sport version has a refined, sporty character, with sport seats and sport steering wheel as standard. Elegance strikes a more extravagant note, with an extremely comfortable, luxuriously equipped interior. Traditionally, the final hurdle in development work is a test drive by the Board of Management, after which the go-ahead is given for production. With the new C-Class, Mercedes-Benz is presenting not only a worthy successor to the highly successful 190 models, but also a car perfectly balanced in all its features.